All right, we've talked about multiplication or power of products, laws of exponents. We learned a shortcut was when the base numbers are the same, we can add the exponents. In powers of quotients or in division, we learned that we could subtract the exponents of like base numbers. 9-4, we talked about negative exponents. To change the sign of the exponent, we simply change it to its reciprocal. And some of you remember as flipping the fraction upside down. Well, now we're going to do power to power, and as you can see right here, the shortcut is going to be to multiply the exponents. Let's look at problem number 1. 7 to the third power raised to the fourth is just like saying 7 to the third times 7 to the third times 7 to the third times 7 to the third. Now, if we used our multiplication rule, we would simply add those exponents, and that would be 7 to the 12th power. Well, looking back at this problem, another way to get 7 to the 12th power would be to multiply the exponents. 7 to the third power raised to the fourth is still going to be 7 to the 12th power. Because you may not have the time, nor do you want to write it out to make it a multiplication problem. Looking at problem number 5, we're going to multiply the exponents. X to the 8th raised to the 5th is going to be x to the 40th. Over here we have 12 to the 7th raised to the 3rd. We're going to multiply the exponents. 12 to the 21st power. Y to the 2nd raised to the 8th. Multiply the exponents, and we get y to the 16th. All right, problem number 9. If we multiply the exponents, 4 to the 3rd raised to the negative 5th, that's going to be 4 to the negative 15th. Our directions did not specifically say write it with negative exponents, so we're going to fix that. And we know from 9-4, in order to write this with a positive exponent, we're going to change it to its reciprocal. 1 over 4 to the 15th power. Here's another one. If we multiply the exponents, we get t to the negative 8th. We're not going to leave it with a negative exponent because our directions did not specifically say to do so. So we're going to change it to its reciprocal, 1 over t to the positive 8th. And we're done with that problem. Sometimes you're going to have more than just a number or a variable. And you have to remember that in between the 6 and the x, there's a multiplication sign. And the 6 doesn't have an exponent written, so it's understood to be 1. You might want to write it in until you get a handle on this. We're going to multiply the exponents. 6 to the 1st raised to the 3rd is 6 to the 3rd. X to the 5th raised to the 3rd is going to be x to the 15th. We have one more step, and that's because we're going to multiply 6 to the 3rd power. So our answer is going to be 216 x to the 15th power. Let's try another problem. Let's go with number 6. 7 has the exponent of 1. There's a multiplication sign in between. 7 to the 1st raised to the 3rd is 7 to the 3rd times a to the 6th raised to the 3rd. We're going to multiply those exponents, and we get a to the 18th. We're going to multiply 7 to the 3rd power, and that's going to be 343 a to the 18th power. Let's go with problem number 10. There's an exponent of 1, negative 9. 1 times 3 is 3, so that's negative 9 to the 3rd power. m to the 9th raised to the 3rd is m to the 27th power. N to the 4th raised to the 3rd is going to be n to the 12th power. Now we're going to need to create some room here. Negative 9 to the 3rd power is negative 729. M to the 27th and n to the 12th. And we're done. That's problem number 10. Now, let's go back and do problem number 2. 5 has an exponent of 1, so that's going to be 5 to the 4th power when we multiply the exponents. B to the negative 3rd raised to the 4th is going to be b to the negative 12th. Again, we do not have any directions that tell us specifically to write it with negative exponents. 5 to the 4th power, that's a positive exponent. That's going to be 625. B to the negative 12th power, that's what we need to change to its reciprocal. So instead of b to the negative 12th in the numerator, we're going to have b to the positive 12th in the denominator. B to the negative 12th is the only part of this problem that we changed to its reciprocal. Here's another one, number 5. 11 to the 1st raised to the 2nd is 11 to the 2nd. Z to the negative 9th raised to the 2nd is z to the negative 18th. We're going to calculate 11 to the 2nd power, and that's going to be 121. We have a negative exponent, so we're going to have to change it to its reciprocal, z to the positive 18th power. And that's the best we can do. Let's go with problem number 7. 4 to the 1st power raised to the 4th power is 4 to the 4th power. G to the negative 2nd raised to the 4th is g to the negative 8th. 4 to the 4th power is 256. This is what we've got to change to its reciprocal, so g to the 8th power in the denominator. Okay. So, each value inside the parentheses, you're going to take its exponent and you're going to multiply it to the exponent on the outside. If you have any negative exponents, only those with negative exponents will you worry about changing them to their reciprocal, just like we did on problem number 5, problem number 7, and problem number 2. One thing I would like you to add to your paper, because on this paper, all the exponents on the outside were positive, so let's write this down. We have 4 to the 2nd power, g to the negative 3rd, raised to the negative 2nd power. Multiply the exponents, you get 4 to the negative 4th power. Multiply the exponents, you get g to the positive 6th power. We're not done because we've got a negative exponent. We've got to change it to its reciprocal. So 4 to the 4th power is 256, but it's negative, so it's going to move to the denominator. G to the 6th power, its exponent is positive, so it's going to remain in the numerator. And that's the best we can do. One more. If we have 8g to the 3rd power, h to the 5th power, all raised to the 0 power, you've got to remember that all of this is being raised to the 0 power. Any number to the 0 power is 1. So if you pick up that calculator, you're working too hard. Okay? This takes care of power to power, laws of exponents. You're going to multiply the exponents on the inside to the exponent that's on the outside. Any negative exponent, you're going to flip to its reciprocal so that all the exponents in your answer are positive. All right, this concludes 9-6.